let's try expanding these fractional exponents a little bit more. As you can see in this this drawing over here, or this equation, that the n is on the bottom, like it's always been. Whatever that number is, 2 or 3 in the last examples, that can go right here. That tells you if you have a square root or a cube root. But then you can also have to the power of 5 or 7 or 3. And so that can go here. Or it can go at the end on the outside. So you notice that m is a top number, like you could have x cubed. But you can also do it after and do the cubed at the end. So you can do the cubed first or cubed at the end. Now I think the easiest is this one. So that's what I'm going to do. You'll see why it's easy just even here in the first example. So first thing that we need to do is put this into radical form. So I've got 8, and then I've got to the power of 2/3. This keeps coming up here. So I'm going to write that, and I'm going to write it both ways, and then I'll show you which way I like. So here's the 8, and then I have, maybe I'll do this here. I've got the 8, and I've got the cube root, and then I can go to the power of 2. So the denominator is right here, and to the power of 2. Or I can put that 2 on the other side. So, or everything is shifting around here. So this is this Microsoft Word for whatever it's worth. And I can not put the 2 on the inside, but I can do the squared after. So why would I want to do, remember I said over here that I wanted to do the m, or in this case the squared, do that last, do that on the outside. So the question is, why would I want to do that? So if I have to evaluate, which is what I have to do next, if I have to evaluate it, I would have to do BEDMAS, which is doing the inside first. So you have to do 8 squared, which is 64. So the cube root is 64. And then you have to know the cube root of 64 is 4. And the cube root of 64 is kind of a hard thing to do. You can make a tree if you want, 8 times 8, and then you can pull that down to 4 times 2, another 4 times 2. And then you can do that, do a 2 times 2, and that 4 is a 2 times 2. And you can bring the 2's down. Looks like things are going even lower because things are crazy right now. And then I need triples. I'm not going to change this, but you could say, well, I've got triple 3's and triple 3's. 2 times 2 is 4. So 64 is just a large number, and I don't want to have to do all of that work. So instead, I'm going to use a smaller number. So I'm not going to do it this way. I'm going to do the squared last. So when I evaluate it, I need to do the cube root of 8, which is 2. So maybe I'll write it again though. So the cubed root of 8, and then I'll square it. So the cubed root of 8 is going to be 2, if you make your little tree, which I'll do with you here, but I'm just going to erase it. 4 times 2, and then another 2 times 2, and bring that 2 down, and there's a triple, which is what I want, and it's only a 2. So the cube root of 8, which you should have memorized now. What number times itself gets you 8? Well, the answer is 2. So cube root of 8 is 2, and then I square it to get 4. So that's how you're going to do this. Now, I don't like squaring it first to get 64, because then I got to do the cube root of 64. What number times itself again gets me 64? And it's like, well, that's 4, but that's maybe not super obvious. So that's why I like to do the squaring last. Or, it's not always the squaring, it's the numerator. So let's do it here, because now we're working backwards. So we've got 81, and we have the denominator, which in this case is a 2. So we're going to do a square root, and then I'm going to cube it. So that's the order that I like to do things. And again, the cube, that's the numerator number right here, and that's what I'll do right there. So I want to square root it first. If you didn't, this is a really an interesting one, because if you wanted to do the so the square root of 81 and you wanted to cube it first, well, then you have to know what 81 times 81 times 81 is, and I don't know what that is. And then after you do that, well, let's just see. I'm just curious now. 81 times 81 times 81. Okay, so, and then I have to do the square root of 531,441, and think of the giant tree that would be. So that's why I don't do it. I'll just do the square root of 81. Remember, square root, the 2 you don't actually need to write, so this is actually just the square root of 81 cubed. Now, if you have to evaluate that, the square root of 81, I'll rewrite it again, because I haven't written this enough, I guess. The square root of 81 is just going to be 9, and then cube it. So 9 times 9 times 9. Now, I don't know what that is, but I do know that 9 times 9 is 81. And if I times that by another 9, so 9 times 1 is 9, 9 times 8 is 72. So this is 729. Okay, let's try some more. So I'm going to do the numerator part first. Sorry, the denominator part first. So the denominator is a 3. So I need to do the denominator is a 3. So the cube root of 64, whatever that is, and then I can do the squared. Let's see if this works. There we go. So the cube root is 64, and then I have to square it. So I do the cube root part first, and then I can do the squared. Apparently I can't highlight though because everything's jumping around. Yep, that's impossible. So the cube root is 64. Now I just know this, the cube root is 64. What number times itself get you 64? And that answer is 4. 4 times 4 is 16. And then times that by another 4, there's 40, and 24, which is 64. So I know that the cube root of 64 is going to be 4. And that's something that you'll probably, if you do any amount of homework, you'll probably know as well. So the cube root of 64, we'll do that first, and then we can square it. So the cube root of 64 is just a 4, and then we can square it. And 4 squared is 16. So let's keep going here. So, I mean, now I got a negative number here, but that doesn't really matter because you're allowed to do cube roots of negative numbers. So I've got negative 27. And the bottom is a 3, so that's my root. So I'll do a cube root. And then I'll go to the power of 4. So that's what I need to do. So the cube root of negative 27, maybe I'll write it down here again. To the power of 4. Now, what number times itself gets you a negative 27? Well, that is just a 3. 3 times 3 times 3 is 27, but then I have an odd number of negatives, so that gets me a negative. And then what's negative 3 4 times? Negative 3 times negative 3 times negative 3 times negative 3. That would get you, I know a negative 3 and a negative 3 is going to be 9, so I do that again. Negative 3 times negative 3 is also a 9, and 9 times 9 is 81. Again, if you had to do this the other way, you would do the cube root of negative 27 to the power of 4. So then you have to go 27 times 27 times 27 times 27, so 27 4 times, whatever that giant number is, then you got to do a tree and try to find your triples. So that would be impossible. Not impossible, but impossible to do that on a test in a limited amount of time. Okay, so let's keep going here. Now I've got negative 32. And I've got a fifth root of negative 32 squared. So negative 32 squared and the fifth root. So first thing I do is the fifth root. Well, first thing I do actually is write it. So the fifth root of negative 32 and then square it. So the fifth root of negative 32 is going to be what number times itself, times itself, times itself, times itself. So 5 times, get to negative 32. And after a while, you just know that number is negative 2. 2 times 2 times 2 times 2 times 2 is 32. And then there's 5 negatives, which will keep it negative. And then I have to do the squared. Negative 2 squared is 4. So some of these are memory things, like the cube root of negative 27. Maybe that's not entirely obvious. You need to know that that's 3. And if it's negative 27, it's negative 3. Or the fifth root of 32. The fifth root of 32 is 2. And if it's negative, it's negative. Cube root of 64. That one took me a little while, but eventually I just remembered, oh, it's 4. And again, you don't have to do it that way. You could, if you wanted to, make a tree here and then just go, okay, that's a 16 times 2. And then the 16 is going to be a 4 and a 4, which is just going crazy. And then eventually you're going to end up with 2, 2, 2, 2, and 2. And you're like, okay, now I need a fifth root. I need a group of 5. Well, that's all of them. So it's just 2 and there's nothing left over, which is why my answer was 2, nothing left over. So you could do these trees, which is probably what we'll end up doing in class, but you don't have to. You can hopefully after a while just memorize it. So now I got the 25. Oh, but I have a negative exponent. Okay, so with a negative exponent, we do the same thing that we did in our exponent law section, and that's bring it to the bottom of a fraction. Problem is there is no fraction, so we need to write it as a fraction. Put the 25 down on the bottom. And once we do that, we can then write 3 over 2. And you'll notice here's a positive 3 over 2. So I'm going to try to make that a little bit clearer, but it's a positive 3 over 2. And because we took this and brought it down to the numerator, it becomes a positive. Okay, so I don't know what my answer is, but I know it's going to have a 1 on it somewhere. So we're going to have a 1 over, and then we want to write this in radical form. So the denominator is a 2, so that's going to be my square root symbol. And then the numerator is a 3, so then I'll cube it. Now, I don't like having to write this 2 right here, so let's rewrite it. 1 over, you don't have to write that, so I'm just going to not do this. I'm going to do the square root of 25. And then cubed. Now, you could, if you wanted to, make a tree, 5 and 5. Oh, that's it. Look for 2s, look for pairs. But you should know that the square root of 25 is just 5. So hopefully you would know that. So let's evaluate it here. And let's actually do that. 1 over the square root of 25, all cubed. And like I said before, the square root of 25 is just 5. And then I can cube it. And then 5 times 5 times 5. Now that you might not know what it is. Hopefully you'll remember it later, but 5 times 5 is 25, and then times that by another 5. I want to write it a little bit nicer here, and I can just keep it here. So 5 times 5, 25. 5 times 2 is 10, plus 2 more is 125. So is that a little bit different? Of course, the fact that it's 1 over, but the negative just made it a 1 over. If you saw a negative here, you can probably just ignore it, do the question like normal, and then make it 1 over at the end. Same with this one. So I can see, okay, well, this is going to have to go down below because it's a negative exponent. So I've got a 1 over 64 to the power of a positive 2 over 3. So let's do that. The numerator and denominator. Okay, so the denominator, let's first actually just write this. 64. The denominator of this fraction is a 3, so it's going to be a cube root. And then when I'm done, I'll square it. Now, I told you before, the cube root of 64, that's one that you'll probably just end up memorizing if you do enough homework. The cube root of 64 is just 4. So let's try this again here. So 1 over the cube root of 64, and then we can square it. I'll try to write this a little bit nicer. 1 over. So 1 over the cube root of 64 is just 4, and then we can square it. And 4 squared is 16. So yeah, it might seem a little strange that all of this goes down to 16, 1 over 16. But the cube root of 64 is 4, and then you can square that. So that's how you do this. You're going to have to practice it. It does take a little bit of time, especially when you think of trying to cube root. Like you notice here, I made no trees at all. And I try to make them ones that you'd be able to kind of memorize. So square root of 81, that's 9. Cube root of 125 is 5. Cube root of 64 is 4. I don't know what cube root of 8 is 2. Cube root of 3, cube root of 27 is 3. So there's ones that you can try to memorize, and if you do them, I did them all here. I think I did them all, but I mean, there's your cube root of 27. Here's your cube root of 64. There's your cube root of 8. So I did try to do, so that's 2, 4, and 3. I tried to do them all kind of right here. So there is a little bit that I did, and then in the notes they're all the same, just some different numbers. But I do have the 8s and 24s and 27s and 32s again. So we'll go on to the next one here in the next video. I think what's going to come after here, example 2 and example 3, is actually a little bit easier than just evaluating without a calculator, like we just did.